Welcome to G Fun Facts Online, where we dive deep into the science behind our everyday world. Think about a perfect day at the beach. You can feel the warm sun, hear the crash of the waves, and feel the sand between your toes. It's an escape, a perfect slice of paradise. But what if I told you that paradise has a hidden, invisible side? A secret world teeming with microscopic life, some of which could make you seriously sick. This is the unseen world that leads to those familiar and, frankly, disappointing beach advisory signs. You know the ones, the big no swimming warnings that can bring your summer plans to a screeching halt. Today, we're pulling back the curtain on the science behind those warnings. We'll explore the invisible life in our coastal waters, how we detect it, and what we can all do to protect our right to a safe day at the shore. So when a beach is closed, it's almost never because of something you can see, like a plastic bottle or a piece of seaweed. The primary culprits are pathogens, a fancy word for microscopic organisms like bacteria and viruses that can cause disease. And where do they come from? The most common source is fecal contamination. It's a gross thought, but it's true. This contamination can come from overflowing sewage systems after a heavy rain, leaky septic tanks near the coast, and even animal waste from both farm runoff and pets on the beach. Swimming in water contaminated with these pathogens can lead to some pretty unpleasant experiences. The most common are gastrointestinal illnesses, which means nausea, stomach aches, and diarrhea. But you can also get ear, eye, and skin infections. For most healthy adults, it's a miserable few days. But for children, the elderly, or anyone with a weakened immune system, these waterborne illnesses can be much more serious. Now, you might think, why don't we just test the water for every single one of these nasty germs? The problem is, it would be an incredibly complex and expensive task. There are just too many of them. So scientists use a clever workaround. They test for something called indicator bacteria. The two most common are Enterococci in saltwater and E. coli in freshwater. These bacteria live in the guts of warm-blooded animals, including us. By themselves, most strains are harmless. But if scientists find high levels of them in a water sample, it's a big red flag. It's a signal that the water has recently been contaminated with waste, which means that other, more harmful pathogens are likely lurking there too. It's like finding a single footprint at a crime scene. It tells you someone was there, and you should probably look for more evidence. Beyond the indicators, there's a whole rogues gallery of other microbes that can be found in the water. Bacteria like Salmonella and Vibrio can cause serious stomach issues. You might have even heard of Vibrio vulnificus, which the media sometimes calls flesh-eating bacteria, capable of causing severe skin infections if it gets into an open wound. Then there are viruses, like norovirus, which is notorious for spreading quickly and ruining vacations, and tiny parasites like Cryptosporidium and Giardia, which are tough little critters, even resistant to chlorine. And sometimes, the threat is visible. We've all heard of red tides. These are actually harmful algal blooms or HABs. They happen when certain types of algae grow out of control and release toxins. These toxins can become airborne, making it hard to breathe even if you're just walking on the beach, and direct contact can cause skin rashes. So how do we know when these invisible threats are present? This is where the science of detection comes in. Local health departments and environmental agencies are constantly monitoring water quality. Traditionally, they've used what's called a culture-based method. They collect a water sample, run it through a filter, and place that filter on a petri dish full of nutrients that these indicator bacteria love to eat. They let it incubate for about 24 hours, and then a technician literally counts the number of bacterial colonies that have grown. The result is given in colony-forming units, or CFU, per 100 milliliters of water. This method is reliable, but it has one massive drawback: that 24-hour waiting period. Think about it. By the time the results come back and a warning is posted, the water conditions might have completely changed. The contamination might have washed out to sea, meaning the beach was closed for no reason. Or worse, The beach might have become contaminated after a clean sample was taken, exposing swimmers to risk. It's like getting yesterday's weather report. It was accurate, but it's not very useful for today. To solve this problem, scientists have developed much faster methods. One of the most exciting is called Droplet Digital PCR, or ddPCR. Instead of waiting for bacteria to grow, this method looks directly for their DNA. It takes a water sample and partitions it into thousands of tiny droplets. Then, a process called PCR amplifies or makes many copies of the target DNA within each droplet. By counting the droplets with bacterial DNA, scientists can get a very precise measurement of contamination levels in just a few hours, not a full day. In fact, San Diego County was the first in the nation to switch over to this same-day testing method. Now, it's not a perfect system. Since ddPCR detects DNA, it can't tell the difference between a living bacterium and a dead one that poses no threat. But its speed is a game changer for public safety. The concentration of bacteria at a beach isn't static. It's constantly changing, influenced by the environment. The biggest factor, by far, is rainfall. A heavy downpour can overwhelm sewage treatment systems, causing them to discharge untreated waste into rivers and oceans. Rain also acts like a giant rinse cycle for our towns and cities, washing everything from pet waste on sidewalks to fertilizers on lawns straight into storm drains, which often empty directly onto the beach. That's why you'll often see advice to avoid swimming for at least 24 to 48 hours after a big storm. Tides and currents also play a huge role. They can flush out a contaminated area with clean ocean water, but they can also trap pollutants in bays and coves. Sometimes, a strong tide can even stir up bacteria that have settled into the sand, bringing them back up into the water column. And finally, there's sunlight and temperature. The sun's UV radiation is a natural disinfectant, killing bacteria in the water. On the other hand, warmer water temperatures can help some bacteria and those harmful algal blooms to grow even faster. Now, a beach closure isn't just an inconvenience. It has real-world consequences. Coastal communities often depend on tourism, and a closed beach means lost revenue. A study of Huntington Beach, California, after a series of closures in 1999, showed a major blow to their Surf City economy. It's estimated that a single-day closure at a popular beach can cost tens of thousands of dollars in lost business for hotels, restaurants, and shops. Over time, frequent advisories can also damage a beach's reputation, making tourists think it's always unsafe, even if the water is perfectly fine most of the time. The good news is, we are not powerless. There are solutions, and we are turning the tide on beach pollution. A huge part of the solution is investing in infrastructure. This means upgrading our wastewater treatment plants and fixing leaky sewage pipes to prevent overflows in the first place. It also means getting smarter about stormwater. Innovative ideas like permeable pavements that let rainwater soak into the ground, or rain gardens that filter runoff naturally, can stop pollution at its source. We've seen real success stories. At Doheny State Beach in California, which historically had problems with high bacteria levels, officials installed a diversion system that captures contaminated runoff and sends it to a treatment plant instead of into the ocean. And in Fingal, Ireland, proactive management plans that targeted specific pollution sources, like runoff from farms, were so successful that they were able to lift permanent do not swim notices from several beaches. And it's not just up to the government. We all have a role to play. Citizen science programs are popping up all over, training volunteers to help monitor water quality and expand our knowledge of local conditions. And every single person who goes to the beach can make a difference with a few simple actions. First, check before you go. Look for posted signs or check your local health department's website for the latest water quality reports. When you're at the beach, practice good hygiene. Shower off after swimming, and always wash your hands before eating. If you have an open cut or wound, it's best to stay out of the water to avoid infection. Try not to swallow the water when you swim. It's the main way people get sick. And be a responsible citizen. Always, always clean up after your pets and leave no trace. Pack out everything you bring in. Looking to the future, beach monitoring is about to get even more high-tech. Imagine real-time sensors floating in the water, constantly streaming data and sending instant alerts to your phone if the quality drops. Drones and autonomous underwater vehicles could one day patrol our coastlines, monitoring vast areas efficiently. Scientists are also building predictive models using artificial intelligence. By feeding a computer data on weather, tides, and recent water quality trends, they can forecast when and where a beach is likely to become contaminated. This would allow for proactive warnings, giving us a heads up before we even pack our towels. So the next time you see a no swimming sign, don't just be disappointed. See it as a sign that science is at work, protecting you from a world of invisible threats. Understanding the science behind these advisories, staying informed, and taking a few simple precautions is a shared responsibility. It's how we ensure that our days at the beach remain a source of joy, relaxation, and safety for us and for every generation to come. Thanks for listening to G Fun Facts Online.